All right, so we are on page 5 right now, and I'm just going to walk you through as many of these examples as you need. I'm just going to start up here with number 13, then I'm going to go over to number 14, and then 15 and 16. So find a problem if you need me to go through it, but I'm just going to start up here with number 13. So the square root of 16, we know that it's 4, and I just want to point out that we're looking for pairs right now. So 4 times 4 is a pair, and the square root of 16 is a 4 that we pull out. Now u to the 4th, y'all, is u times u times u times u, so I have 4 of them. And if I'm looking for pairs, I'm pulling out that u. Then here, I'm pulling out another u. And then within the v's, I am pulling out just one set of the v's. Now underneath the radical, I still have this final v right here. And right here in blue, u times u is u squared. So the final answer you see that I have here boxed is it's a 4u squared v times the square root of v. For number 14, my method here is I'm looking for perfect square factors. 28 I know is 4 times 7, and I do know the square root of 4 is 2, so that's why I have a 2 out here for my answer. Now for the x's, x cubed, y'all, is 1, 2, 3, and y cubed, there's 3 of them. So for the x's, here is a pair. The square root of x squared would be x, so that's pulled out here. For the y's, I have a pair to pull out, and so the square root of y squared is y. And then notice underneath my radical, it's this 7, the x, and the y that stays under the radical. I wanted to remind you guys that this is called the radical, and in here is called the radicand. So for number 13, the radicand was just letter V. For number 14, the radicand is 7xy. All right, now we're on number 15. And number 15, again, we know 36 is a perfect square, so the square root of just 36 is the 6 that I have here. It works right here for me to circle a pair. Now x squared, the square root of x squared, we've already talked about that. The square root of x squared is x. So that's why I have an x out here. There's a pair. And then here, for the 3, I can pull out there's a pair that I can pull out. So this is the pair that I've pulled out. The square root of y squared is y. And then I just have one y left right here as my radicand. For number 16, 384. There's a very good chance for number 16 that you have a prime factor tree, but I happened to catch with the shortcut that it is the product of 64 times 6. So the square root of 64 is where I'm getting this 8. And now I'm going to kind of talk to you guys about the shortcut with the exponent here. I want to remind you guys that the index here is called a 2 when you don't see it. And there's a shortcut if you look at the exponents, and I'm going to go back actually now to all the problems that we've done to talk about a shortcut. So for this one, how many times does 2 go into 4? It goes into it twice, so that's the 2 that you see here. How many times does 2 go into 3? It goes into it once, and then we'd have 1 left over. And anytime the exponent is 1, we don't have to write it, so we wouldn't need that 1. All right, let's try the next one. How many times does 2 go into 3? It goes into it once with 1 left over. How many times does 2 go into 3? Once with 1 left over. All right, let's try number 15 with the shortcut. How many times does 2 go into 2? Once with none left over. How many times does 2 go into 3? Once out here with 1 left over. So now for this one, 2 goes into 2 twice with no x's left over. And 2 is going to go into this 3 once with 1 of them left over. Your backup plan to circle away the pairs works. Here's a pair of x's. Here's a pair of x's. So it took out 2 pairs of x's. And then with the y's, I'm taking out a pair of y's. It's out here. And then 1 y is left on the inside. All right, so now we're on number 17. And I'm going to highlight that now just in case anybody is like pausing the video or skipping ahead. We're on number 17 now. So for number 17, once again, the 96 part, the square root of that, you might still be making a factor tree, but I like to go for the shortcut of the perfect squares. So 96 is divisible by 16, which is a perfect square. Now the other thing I want to point out here for number 17 is that it already has a 7 on the outside. So the 7 on the outside is going to stay there. And when I take the square root of 16, that's why you see this 7 times 4. The square root of 16 is 4. Now the 6 stays in my radicand. And then here for the exponent, take a look at my shortcut. 2 goes into 3 once, so an m comes out, and then 1m will stay in. So that 7 times 4 is where I got the 28. It's tough to see it in my video, but there is a little m written right there, so there's an m that I've pulled out, and then 6m is the radicand. Folks, at any point, if you just want to pause the video and try to work forward and work ahead and then just check the video to see if you're right, feel free to do so. But now I'm on number 18. And I recognize that 72 is the product of 36 and 2, and 36 is a perfect square. Now I already have a 6 that's on the outside, so I'm going to leave the 6 on the outside. And then the square root of 36 is 6, so that's where I got this 6. Now there's a 2 still underneath my radical, and then the square root of x squared is x. And actually, let me wipe that one out. There's a little typo in my video. Since there's only 2 x's here, one pulls out, and none of them would stay in. And for that one, we end up getting 36x times the square root of 2. All right, for number 19, 150 is the product of 25 and 6, and I have a negative 6 already out here. So the square root of 25 is the 5 that I've pulled out, and then I just have 6r left. 2 doesn't even go into 1, so the r has to stay. There is no square root of r. It's going to stay right there. All right, for number 20, once again here, 80, the part right there, you might be still drawing a factor tree for the 80 and circling away your pairs. But if you circle away your pairs, you've circled 2 sets of 2. So you've pulled out a 4 that we multiply by the 5 that's already out here, so that's the 20. And then, I don't know why I did that again on my answer key here, y'all. Let me go ahead and fix that for the next one. When we have the square root of a squared, the a comes out and should no longer be there. All right, that's my mistake. Now here we are on number 23. So we have a negative 4 already out here, and underneath the radical there's an 8 that we're going to be multiplying it by, and out here we end up getting the negative 32. Again, you might be doing the prime factor tree, and you might be multiplying negative 4 times 2 times 2 times 2 if you've pulled out a 2 times 2 times 2. But here I just went ahead and saw that 64 times 3 is 192, and the square root of 64 is 8, and that times negative 4 is negative 32. Now the 3 times the x that's on the inside stays. This exponent right here is just a 1, and since 2 doesn't go into this, we should still have 1 left over. All right, now we are on number 24, and right here, 4 times 2 is how I get 8, and the square root of 4 is 2. And now times the 2 that was already out here is 4. The square root of p squared is p. And the square root of q cubed, we'd get 1 pair that comes out and 1 will stay in. 2 goes into 3 once and 1 will stay in. And then the r will also stay underneath the radical. All right, here we are now. We're on number 25. We're almost done here. So 36 is a perfect square that goes into 216. So it's 36 times 6. And since the square root of 36 is 6, I've multiplied it by this negative 4 to get the negative 24. Now the 6 right here stays underneath the radical. That's part of the radicand. All right, now I've got the square root of x squared, so 1 pair comes out. And then the square root of y squared, so 1 pair comes out. And then there's nothing to remove with the z. So our final answer here is going to be negative 24xy, and then we have the square root of 6z. Finally, here we're on the last problem. Now we're on number 26. And 4 times 6 is how I can get 24, and 4 is a perfect square. So the square root of 4 is 2, and that's now out here with the negative 3 to get my negative 6. Now this index of 2 goes into 4 twice, so I have a squared out here. 2 goes into 2 once, so I have b out here. And 2 goes into 3 once, and I should have right here another c. My apologies. And so we circle away 1 pair. We should have a c in here, and there should be a c here. So our final answer for number 26 is negative 6a squared bc, and then times the square root of 6c. And that concludes the video on page 5. Thank you.